Hey guys, what's going on? It's Dave with Evil Eye Gaming. Today we're going to continue on with our third-person cover shooter, and we're going to continue developing the AI for the assault. And the last time we left off, we ended up leaving our enemy character so that he would come at our player character and start shooting, but as of yet, he's not aiming at our player, and he's also not able to handle what happens when the player moves behind the enemy but stays within a certain distance. So we're going to address those issues today. So the first thing we're going to have to do today is we're going to have to grab some animations from our animation pack. So we're going to have to go into our Scratch project. So I'm going to open up the launcher, and I'm going to open up our Scratch project. And in the In Place Animations folder, we're going to end up searching for the walk animation. And particularly we want the rifle _ walk. And there's two animations in here that we're looking for, the rifle walk backwards loop and the rifle walk forward loop. And I'm going to do the same thing that we did before, where I'm going to go ahead and right click on it, and we're going to duplicate it, and we're going to name it the same, with the exception of, instead of rifle, we're going to put in enemy. Now, I've already done this, so I'm just going to go ahead and delete that one. But we need that walk forward animation and the walk backwards animation. And then we also need to search for the rifle _ strafe. And we need the 6 additional animations that are named rifle strafe left 135 loop, the rifle strafe left 45 loop, the rifle strafe left loop, and then the rifle strafe right 135 loop, the rifle strafe right 45 loop, and the rifle strafe right loop. We need all 6 of those animations. So once they've been renamed, we can search for enemy, and we can grab the enemy strafe left, the enemy strafe left 45, the enemy strafe left loop, the enemy strafe right 135, the strafe right 45, and the strafe right loop, as well as the walk forward and the walk backwards loop. And we're going to go ahead and right click on those animations. We're going to go to Asset Actions, and we're going to go Migrate. We'll hit OK. And we want to select the Content folder for our third-person shooter, and we'll go ahead and click OK. And the content will be migrated over. So we'll close out of our Scratch project, and we'll go back into our third-person cover project. And then we can go into this Rifle Anim Set Pro folder. We can open up our animations in place, and they aren't quite showing up yet, so I'm going to go ahead and close out of the project and then relaunch it. And we'll see that the animations are in place, so if they don't show up right away, just close out of the project and reopen it. And I'm going to take these animations, and I'm going to go ahead and move them over to our Characters, Animations, Enemy Animations folder. So I will just go ahead and select them, drag them, and drop them into the Enemy Animations folder. And we'll click Move Here. Then we'll select our Rifle Anim Set Pro folder. I will right click and we'll hit Delete. And we'll hit Force Delete. And then we're going to go into our Enemy Animations folder, and we're going to see the 8 animations that we just dropped in there. So I'm going to go ahead and I'm going to select those 8 animations that we just dropped into place. We'll right click, we'll retarget anim assets, and we'll retarget skeleton on existing anim assets. We'll select the UE4 mannequin skeleton and hit select, and they will be reassigned to that skeleton. So we'll go ahead and hit save all. And next we're going to have to go into our enemy character folder, and we're going to go into our base enemy anim blueprint. Now we're going to go into our state machine, and we're going to open up our movement node, and I'm going to double click and open up our enemy movement Blendspace. So right now we just have running animations of him running at the same speed in different directions. So in our asset browser, I'm going to search for enemy, and first thing I'm going to do is I'm going to grab this enemy idle animation, and I'm going to drag it, and I'm going to replace all of the animations at the bottom. So all you have to do is click and drag the enemy idle and drop it onto the existing animations that are already in place. So now when we're towards the bottom, he barely moves at all. Except it looks like I missed this one. So we'll go ahead and drag and drop that one in place. So all the animations at the bottom have been replaced. So we're going to want to go ahead and put our walking loops in place right at the center line, which is about 250. Since our y-axis here is between 0 and 500, putting it in the middle will sit at 250. So as we go down the animation list here, we're going to find the walk backwards loop, and I'm going to drag and I'm going to drop these horizontally at the center, or vertically at the center, on the very edges. So the very right and the very left should be the walk backwards loop, and then the very center should be the walk forward loop. And then we're going to go ahead and take our strafe left loop, and you want to make sure that you're not selecting the strafe run loops. So we'll take our strafe left 135 loop, and this will be one in from the left. We'll then take the strafe left 45, and this will be one to the left of the center. And then we'll take our strafe left loop and put it in between those two. Then we're going to do the same thing for the right-hand side. So we'll grab the strafe right 135 loop, and we'll drag it one from the right. We'll grab the strafe right 45 loop, and it'll be one to the right of center. And the strafe right loop will be in between those two. So when we're moving at 250, he is going to use these walking animations instead of the running animations. And then if we go up to 500, he's going to use the running animations. So we can go ahead and save. And we're going to go back to our graph. So the next thing we're going to do is we're going to go ahead and go over to our event graph. And right now, all we're really doing is calculating our speed and direction. So I'm going to make a couple of adjustments here. Move these over and out of the way. I'm going to drag pretty much everything except for the is valid and the try get pawn owner to the right. And I'm actually going to go ahead and shift these to the right a little bit. Reason being is I want to make a variable for this delta time x. So we're going to go ahead and right click on the delta time x and promote to a variable. And we're going to call this delta t. And then we'll go ahead and connect this in line. And next, after the is valid, I'm going to drag out and we're going to get a sequence. And then from our then one pin, what we're going to end up doing is we're going to cast to our character. So from our try get pawn owner here, I'm going to drag out and we're going to go ahead and cast to our base enemy character. And we'll connect our then one pin to this cast. And then as our base enemy character, I'm not going to use this just quite yet, but to prepare for it, I'm going to drag out, and we're going to go ahead and get the combat type. And then I'm going to go ahead and promote this to a variable, and we will simply call it combat type. And then we'll go ahead and connect our execution pin into it. And then from our cast, once again, we're going to drag out. And we're going to go ahead and get the player character reference. So this is the reference to our actual player character. And the first thing we want to do is we want to drag off of our player character and we want to search for is valid. And we want to select the is valid option with the question mark. And what this is going to do is it's going to check to see if this player character references something that actually exists. So if this value hasn't been set yet, it won't do anything following the is valid statement. And then from our base enemy character cast, I'm going to go ahead and drag out, and we're going to go ahead and get mesh. And this will be a reference to our enemy character's actual mesh. And then we also want to drag off from the reference to the player character, and we want to go ahead and get the mesh as well. So now we have a reference to our base enemy's mesh, and we have a reference to our character, or our player character's mesh. So what we're going to do at this point is from the enemy character's mesh here, I'm going to go ahead and drag out, and we want to get socket location. And we don't actually want to get a socket, we want to get a bone. And one thing they don't really explain very well is using get socket location can also get locations of bones, not just sockets. So if you type in the socket name a valid bone name, you will get the location of that bone on the skeleton. So in the socket name here, I'm going to insert hand_R. And I want a reference to his right hand, because his right hand is actually holding the weapon. And this will be the closest thing that we can get to where he is actually pointing to. And then I'm going to go ahead and I'm going to duplicate this get socket location. I'm going to plug our reference to our player character's mesh into it. And for the socket name here, I'm going to select spine_03. And if we actually look at the skeleton, the spine 03, if we select it, is right about center of mass for the character. So that's a good point to be aiming at. So go back to the graph, and we want to find the look at rotation from the enemy character's hand to our player character's spine. So we'll drag off from our get socket location, and we will find the look at rotation. So the start is going to be the hand on our enemy character, and the target is going to be the spine on our player character. Next, we want to get the rotation of our enemy character. So I'm going to put in a reroute node here, and we're going to drag this out, and we're going to go ahead and get actor rotation. And then we want to find the difference between these two rotations. And so from our find look at rotation, I'm going to drag out, and we're going to search for the delta. And we'll connect the get actor rotation into the B. And this will return the difference between the rotation from our hand to the spine between the get actor rotation, the actual rotation of the actor. So up a little further, I'm going to go ahead and we're going to actually create two new variables. The first one is going to be the enemy pitch, and this is going to be a float. And we'll create a second float that will be the enemy yaw. And I'm going to go ahead and I'm going to drag references to the enemy pitch and the enemy yaw out onto the graph. And I'm going to right click in the graph, and we're going to search for make rotator. And we're going to plug the pitch into the Y pitch and the yaw into the Z yaw. And from our make rotator, we're going to go ahead and drag out, and we're going to search for the R interp 2. And we're going to connect the delta rotator into our target. And we're going to need the reference to that delta time, so I'm going to drag out our delta t and plug it into our delta time. And then for the interp speed, I'm going to set this to 10. And there's no hard and fast rule really on the interp speed. Basically, the smaller the number is, the slower the change is going to occur between the current rotation and the target rotation. If you set it to 0, it will happen instantaneously. But beyond 0, any number that you set it will be slower the smaller the number is. So from our return value on our R-interp, we want to drag out, and we want to break the rotator. And then we're going to drag out from our pitch, and we're going to search for a clamp angle. And we want to clamp our pitch between 90 degrees each direction. So the min degree will be -90, and the max angle degrees will be a +90. And then I'm going to go ahead and duplicate this clamp angle, and we'll plug the Z yaw into our angle degrees. And I'm going to set the min to -179 and the max to 180. And then we're going to have to set our pitch and a yaw. So I'm going to drag out our pitch and our yaw. And then we'll plug the top one into our pitch and the bottom one into our yaw. And we can go ahead and connect up the execution pins. And then I'm just going to go ahead and tighten up this graph a little bit. So once that's complete, I'm just going to select this entire section that we use to determine our pitch and our yaw. I'm going to put a comment box around it, and we'll call this aim at player. And we can go ahead and compile and save. The next thing we're going to have to do is we're going to have to add in our aim offset. So we're going to go back over to our state machine, and we're going to first open up the idle animation state. I'm going to drag this over, and in our asset browser, we're going to search for that rifle aim offset that we created. We'll drag this onto the graph. We'll plug our enemy idle into the offset and the offset into the final animation pose. And we'll find our enemy pitch and our enemy yaw and plug those in appropriately. And I'm just going to grab the offset and the variables, and I'm going to copy them. And we're going to back out and go into our movement. I'm going to drag this off to the side, and we're going to paste in our aim offset. And we'll go ahead and connect that in. And we'll go ahead and compile and save. And we can test this out. We'll go ahead and hit play. And we'll go ahead and get our character's attention, and he sees us. But the aim is still a little bit off, but he is tracking us at this point. So if we move left and right, he's pivoting to aim with us. So we're just going to have to make a couple of slight adjustments. So I'm going to exit out, and we're going to back out to the very top of our anim graph. And we're going to drag our new state machine out, and I'm going to right click on the graph, and I'm going to search for transform and modify. And we'll see there is a transform modify bone. So I'll go ahead and connect our state machine into the component pose and the end result into our final animation pose. And we'll select the transform modify bone. And the bone we want to modify is his right upper arm. So in bone to modify, I'm going to select the upper arm L. Then for translation mode here, actually for rotation, under rotation mode, we're going to select that, and we're going to add to existing, and component space is fine. So we'll go ahead and hit compile and save. And if we select the transform modify bone, in the preview window, you'll see that there is a manipulator that we can use to rotate the bone. And it actually looks like he selected the wrong one. We want his right arm. So we'll go back to the bone to modify, and we'll select the upper arm right, and compile and save, and it's now on the correct bone. So one thing you'll notice about the idle pose here is that he kind of points his weapon in an upward direction. So I'm going to go ahead and I'm going to aim that down a little bit. And we'll go ahead and compile and save, and let's test it out. So we get his attention. He turns around, he's shooting at us, and when he is right away from us, it looks pretty spot on there that he's aiming for our center of mass. And if we move to the side and let him fire again, he's still aiming at our center mass. So that looks pretty good. But you'll notice that his hand position is offset again. So we want to create a IK bone for his left hand. But you'll notice that there is a difference between where the handholds are on the assault rifle, on the grenade launcher, and the shotgun. So we're going to have to create a multi-tier approach to this, which is why I took the combat type enum variable in our event graph. So I'm going to go ahead and I'm going to disconnect this final animation pose here, and I'm going to drag this down a little bit. And from our end of our component to local, after we modify the bone here, I'm going to go ahead and I'm going to drag off, and I'm going to search for cache. And we want to select a new saved cache pose. And I'm going to go ahead and rename this, and we're going to call it a base pose. And the reason we're using a base pose is that you can't just split these connections off in the animation graph. For whatever reason, this is the way they designed it. So what you're going to do is you create this cache pose, and then you can call on this cache pose however many times you need to. So we're going to go ahead and I'm going to drag out and get the combat type variable. And from here, we're going to drag out, and we're going to search for blend poses. And we're going to select the option for blend poses by combat type enum. Now, this doesn't naturally have the different combat type variables exposed here. So what we're going to have to do is right click, and down towards the bottom, there is an add pin for element. And I'm going to select the assault. Then we're going to do it again for cover. And then we're going to do it one last time for heavy. So this gives us access to change our animation based on the combat type variable. And we can connect this output into our final animation pose. And then we're going to go ahead and we're going to right click in the graph, and we're going to search for cache again. And we're going to select the used cache pose base pose. And we have 4 different options here: the default pose, our assault pose, our cover pose, and our heavy pose. So I'm going to go ahead and make a total of 4 of these. And the top one, I'm just going to take this and straight plug it into the default pose. We're not really ever going to use this default pose, but it's there just in case. So from our use cache pose, the second one, I'm going to drag out. And actually, I'll right click in the graph. And we're going to search for 2 bone IK. And we're going to do the same kind of thing that we did with our player character in adjusting the hand relative to his other hand. So we'll connect the cached pose into the component pose. And then we'll connect the output into the assault pose. Now, as you can see, I already changed the weapon that the character is holding to the assault rifle. This combat type enum is not going to affect this preview in any way other than the actual posing of the mannequin. So what we're going to have to do is you're going to go over to skeleton, and under weapon socket here, right now I have the white shotgun in place, but I'll show you how to change this weapon real fast. We're just going to right click on it and select delete. And then we'll select the socket. We'll right click, add preview asset. And then since we're dealing with the assault first, I'm going to search for the shotgun. And we'll select the white shotgun. So now he has the white shotgun in place of the assault rifle that was there before. We can go ahead and move back over to the graph here. And then we're going to select our 2 bone IK, and we're going to have to configure it. In the options, under IK bone here, the bone that we want to affect is our left hand. So we'll select the hand _L. And for effector location space, we want to set this to bone space. And as we scroll down, the effector bone space name is going to be his other hand. Since we're working with the hand L, we want to associate this with the hand underscore R. And then for the joint target here, we're going to go ahead and select the bone space. And we're going to have to set the joint target space bone name, which, let's check on the skeleton to make sure. Right above the hand is the lower arm underscore and then the side. So since we're affecting the hand left, we were going to get the lower arm underscore L. And we can go ahead and hit compile and save. And just as before with our player character, it went ahead and moved the left hand right on top of the right hand. So we can go ahead and use the manipulators here and change the position of his hand so that it looks like he's actually holding the shotgun. So that looks pretty good to me. And then we want to set it up so that we can adjust the remainder of the poses as well. So I'm going to go ahead and copy these local to components, the two IKs and the component to local, and I'm going to duplicate them for the remaining two poses. And it looks like it reset this here. So I'm going to delete that and I'm going to duplicate it again and pop it into place. And then we can connect our cache poses into the local to component conversions. And then go ahead and connect the conversion out into the cover pose and the heavy pose. So that way you can go ahead and change the preview asset in here and change the 2-bone IK and where the hand sits on the weapon based on the weapon that he is currently holding. Now, I'm not going to go through setting up these 2-bone IKs right now for the assault rifle and for the grenade launcher because we're not really using it. But that is going to be available to us in the future. So I'll go ahead and clean this up. And then when you do go and end up changing the hand poses for the other weapons, you're going to want to make sure in order to use these different paths here, after you set the weapon to the assault rifle, you're going to want to go ahead and select the combat type and select cover, and it will use that correct combat type in the blend poses. So we're going to go ahead and compile and save. And that's going to be it for our NMBP. So I'm going to go ahead and we're going to close out of our base enemy NMBP. The last thing I want to do is I want to go ahead and adjust our enemy character's behavior tree, because right now he can't handle what happens when we move behind him and he's in close range. And also I want to make it so that he doesn't shoot at our player until he gets into a certain range. So if the enemy is like 200 meters away from us, there's no real point in him firing his shotgun. Now, you may have noticed that I changed up the default map a bit here, and it was really easy to do. I just basically selected the floor here and then changed the scale to make it more of a long corridor-like. And then from the basic tab over here, I dropped in 4 cubes and stretch them to be walls around and make an enclosure. And then I just ended up copying and dragging around several of our base cover objects onto the map so that I could use them for testing purposes. And the real reason I ended up doing this is I wanted my test map to kind of reflect the way I want the game to be laid out. And I'm designing this game primarily to be sort of a quarter linear shooter. So we're going to be traveling in one direction down a quarter, and the enemies are going to be coming at us from the front. But we still do need to address what happens if, for some reason, we get ahead of an enemy. And the behavior tree that I designed to do this is going to be limited by this factor. It's definitely not perfect, and it's not applicable to all situations, but it's pretty basic and straightforward and gives me the easiest time in setting up this behavior tree. And if you're trying to work on an open world system, you're probably going to have to do something a little bit different, like get the character to rotate in place. But I don't particularly really want to mess around with that right now. And seeing as how I'm just trying to get a prototype working, I'm going to go for the most simple, straightforward answer that I can possibly find. So, to kick this off, we're going to go ahead and go into our enemy characters folder into the AI, and we're going to go ahead and open our enemy AI behavior tree. And I'm just going to move some stuff out of the way over here. So right now, from our combat selector, we go straight into our simple parallel, where our enemy character starts attacking the player while he's moving at us after we set the walk speed. And then we use this is at location here to prevent him from coming after us until we're a certain distance away from us. So I'm going to drag this down and out of the way. And the first thing I'm going to address is how do we set it up so our enemy character just moves at us and doesn't start shooting until he gets within a certain range. So what I'm going to do is from our combat selector here, I'm going to drag off and I'm going to search for a selector. And I'm going to connect from our selector down to our simple parallel. I'm going to go ahead and grab and move the assault decorator up to our selector. So this will be our main node for the assault condition. And we'll move this over to the side a little bit. And we want to find out how close the enemy is to our player character. And we've been using this is at location here. But the problem with this is at location is that it can't be set to self-abort. So we need a function, or a decorator in this case, that is going to allow us to set it to self-abort. So what we're going to do is we're going to go to the top here and we're going to select a new decorator. And we're going to go back to our main window and we're going to rename this new decorator. So right click, rename. And I'm going to call this check distance to player underscore BTD. And we'll go into our check distance to player BTT. And at the top under functions here, next to the adding a function, there's actually a override. I'm going to go ahead and click on that override. And we're going to select the perform condition check AI. I'm going to drag this return node off to the side here. And we're going to want to get a reference to our player character from the blackboard. So in the variables, I'm going to add a new variable. And we're going to call this player character. And we're going to set it to type blackboard key selector. And we're going to make it public. And we'll go ahead and get a reference to this. And from our player character reference, we're going to drag out and get as actor. And then we're going to want to go ahead and get our player character's location. So I'm going to search for get actor location. And we're going to want to compare it to the location of our enemy AI. So from our controlled pawn here, we want to get that actor's location. So I'll just duplicate this get actor location. And I'll plug our controlled pawn into our get actor location. And then to find the difference between these 2 points, I'm going to drag off of our get actor location. I'm going to search for a minus. And we'll select a vector minus a vector. And plug our other get actor location into the other pin. We then want to drag off the subtraction, and we want to search for vector length. And this will give us the length of the vector in a float value. So we're going to compare this value, and we want to see if it's less than a certain amount. Now what that amount is, we want to make flexible to us in the blackboard or in the behavior tree. So I'm going to right click on this tab and we're going to promote to a variable. And I'm going to call this the distance threshold. And I'm going to make this variable public as well. And then we'll take the result of our check and plug it into our return node. So what this condition check will do is it will get the location of the enemy pawn. It will get the location of our player character, find the difference between the two, get the length of that vector, and then compare it to our distance threshold. And if it's less than our distance threshold, it will return true. Otherwise, it will return false. And that's all we're going to need to do in here. So we're going to go ahead and compile and save, and we can close this. And in our enemy AI behavior tree here, for the simple parallel, I'm going to right click on it, and we're going to add a decorator, and we're going to add that check distance to player BTD. And we can select this, and we want to set the player character reference to player character on our blackboard. And then for the distance threshold here, I'm going to set this to 1100, which is going to be 11 meters. And we want to set the observer aborts to self. And we can go ahead and save. So what this node is going to do is it's going to run when the distance threshold is less than 1100. Next, we're going to drag off of our assault selector here. And we're going to select a sequence. And we're going to right click and we're going to add a decorator. And once again, we'll add the check distance to player. And we'll click on it. We'll set the player character to the player character blackboard number. Then we'll set the distance threshold to 1100. And we'll set the observer aborts to self. And then most importantly, under condition here, we'll set the inverse condition to true. So this will perform when the opposite of our simple parallel setup is true. And we can actually set the node names on here. And I'm just going to call these check distance to player. And then we have to figure out what we want to do in the sequence. Well, we want to go ahead and set the walk speed again. So I'm going to duplicate our set walk speed node and plug that into our sequence. And I'm going to set the max walk speed here to 500. So he's going to move faster when he's outside of 10 meters from us. And then we're going to go ahead and issue a move to command. And we'll select that, and we want to make sure that the blackboard key is set to player character. And we can set the acceptable radius to really anything, because this sequence is going to shut down as soon as we get within the 1100. So this value really has to only be anything less than 1100. So I'll just leave it at the 5 as the default. But the other thing I want to make sure that we're doing is, if we have already gone into the assault mode and we come out into this mode, we're going to still be firing the weapon because we haven't done anything to stop firing our weapon at this point. So if we move into this node, it'll execute the attack player. And then if we run away from him and we get over 11 meters away, we have nothing to stop the player from being attacked. So we're going to have to create a new task that is going to stop our weapon from firing. So I'm going to go ahead and click on New Task, and we want to set it to our blueprint base. And we'll go back to our main window, and I'm going to rename this. We'll call it Stop firing weapon underscore BTT. And we'll go into our stop firing weapon BTT. And this one's going to be really easy. So we're going to right click and we're going to search for the execute AI. And we'll select the event receive execute AI. We're going to take our controlled pawn and we're going to cast to our base enemy character blueprint. And then from our base enemy character, we're going to go ahead and call the stop fire weapon function. And then out the end here, we'll drag out and we'll set finish execute. And we want to set the success to true. And we'll go ahead and compile and save that. And we can close out of this. And from our sequence here, I'm going to drag off to the left. And we're going to search for that stop firing weapon BTT. And the node name, I'm just going to call stop firing weapon. And so this is going to handle what happens to our character in the instance that we're over 11 meters from him. He's going to run at us. And then once he goes ahead and gets into less than 11 meters, he's going to start attacking the player. He's going to slow down his walk. And he's going to move at us until he gets about 300 or 3 meters away from us. And he won't start chasing us again until he gets about 7 meters away. But we also have to handle now what happens when we run past him. So we're going to have to create a new check that is going to see whether we're in his front firing arc or not. So to set this up, I'm just going to drag the sequence and these nodes down out of the way. And from our parallel, I'm going to drag out and I'm going to search for a selector. And I'm going to connect the selector to our sequence that is already in place. And I'm also going to select a move to task as the other option for the selector. But we have to create some sort of decorator that is going to define whether each of these nodes actually fires or not. So we're going to go ahead and we're going to create a new decorator. And I'm going to go to the main window and we're going to go ahead and rename this. And I'm going to call this check firing arc underscore BTD. And if you haven't noticed for the naming conventions yet, basically the last 3 letters, the BTT is for a task, the BTS is for a service, and the BTD is for a decorator. So we'll go into our check firing arc BTD. And once again, we're going to want to go up to our functions and select override. And we want to select the perform condition check AI. And we'll go ahead and drag the return node off to the side here to give us some room. And the first thing we want to do is we want to go ahead and get the location of our controlled pawn. So we'll drag off from controlled pawn here. We will get actor location. And then once again, we need a reference to our player character. So we're going to add a new variable. We're going to call this player character. I'm going to make this a Blackboard key selector, and we'll make it public. So I'll drag out a reference to our player character. And from there, we're going to get as actor. And then I'm going to duplicate this get actor location again. And we'll connect the value of our actor into the get actor location. So the next thing we want to do is we want to find the look at rotation. So from our get actor location of our controlled pawn, we're going to drag out and we're going to search for the find look at rotation. And we'll connect the target up to our player character's location. And we want to find out how much this is different from our pawn's rotation. So I'm going to drag off from our controlled pawn here, and we're going to get the actor rotation. And once again, we're going to drag off of our find look at rotation, and we're going to search for delta, which will give us the difference between two rotations. And we'll connect the get actor rotation of our pawn into the B. And then from our delta rotator value here, we're going to drag out, and we're going to go ahead and break the rotator. And the only thing we're concerned about here is our yaw. So I'm going to drag off from our yaw, and I'm going to search for absolute, and we want to compare this value. So we want to see if it's less than a specific number, and we'll set this to, let's say, 85. And then we're going to drag the result into our return node. So what is this function doing? Very similar to the way we're setting up our aim offset. We're basically getting the location of the enemy character, and we're getting the location of the player character. We're finding the rotation to look from our enemy character to our player character, and then we're comparing that to the enemy character's rotation. We want to see what the difference is between where he's looking right now and where the player character is. And then from that difference, we're just basically grabbing the yaw, and then I'm using this absolute here to make it a positive number. So it really doesn't matter if it's a negative 85 or a positive 85, because if we remember from setting up our aim offsets, directly forward is 0 degrees, straight to the left is negative 90, and straight to the right is positive 90. So we want to see if this value is less than 85. So this return node here is going to return true if we're in the front 170 degree arc of the enemy character. So we're going to go ahead and compile and save this. And we can close out of our check firing arc BTD. And here I'm going to select the sequence, and we're going to right click. We're going to add a decorator, and we're going to go ahead and check the firing arc BTD. And we'll select this. And we'll make sure the player character is set to our player character blackboard value. We want to set observer of vorts to self. And for the node name, we're going to go ahead and call this we'll just call it what it is, check firing arc. So this check firing arc is going to return true if we're in the front 170 degrees. And it will run this sequence. And then we'll select the Move To node here, and we'll go ahead and right-click and add a decorator. And we're going to go ahead and add that check firing arc BTD as well. We'll select that. We'll make sure that the player character is set to the player character blackboard value. I'm going to leave the observer of vorts to none. And then we're going to select the node name. We'll set check firing arc. And then finally, we want to make sure that the inverse condition is set to true. So we'll fire when we're not within that front 170 degree arc. And then finally, for the move to, I'm going to set the acceptable radius to 300. So we'll go ahead and compile, or actually just save that because there's no compile option, and we'll give it a try. So I'll go ahead and hit play. I'm going to grab his attention. So he comes around, he points at us, and he tracks us, which we already took care of. Now, if we go ahead and run to the other side of him, he goes ahead and he turns around, and we can kind of like cycle around him a little bit. And it isn't perfect, but once again, I'm planning on it being kind of like a corridor shooter, so it doesn't have to be super accurate. more or less, I'm expecting that the player is just going to sprint by a character at the worst case scenario. And we'll also sprint way down to the other end. And you can tell now that the enemy character has stopped firing. We go into our behavior tree here. It is doing this check firing arc, so it's not aborting out of this. So it hasn't checked the distance to the player over here. So you're progressively following this. So I'm going to stop the simulation, and I'm going to select the check firing arc, and we're going to go ahead and set the observer aborts to self, and we'll save, and let's test it out again. I'm going to hit Shift F1 to get control of the mouse and drag our window off to the side. And I'm going to bring up our behavior tree so we can actually watch the behavior tree fire as we test it out. So right now, he's moved to us. He set his walk speed at 250, and he's within 7 meters of us, so he's not really doing anything. And we can kind of back around and move around a little bit, and he's just going to stand there and aim at us. So if we move around to the other side of him, he goes ahead and fires that move to until we are in his front firing arc. Now, if we go ahead and sprint all the way out so that we get out of that 11 meter threshold, for some reason, he still seems to be firing. So let's take a look at what's going on here. And it looks like I made a mistake, and I set the distance threshold to 11,000, not 1,100. So we'll go ahead and correct that, and we'll test it out once again. So bring up our behavior tree, and go back into our window. So now he sees us, and he comes running at us. So we'll go ahead and sprint to the other side. And once we get outside of 11 meters, he stops firing his weapon, and he comes running at us. And then once he gets down to that 11 meter threshold, he starts walking and begins firing again. So if we sprint by him, he's moving towards us again, and he's going to close the gap down to that 3 meters. And then we can kind of move around a little bit. And once we get outside of 7 meters, he's going to go ahead and try and pursue us by walking again. So that's going to complete our assault phase for now. I may or may not add features in the future, depending on actual gameplay when we get something a little bit more playable. But we still have to fill out his actions to take cover, and we have to fill out the actions for firing when he has a heavy weapon. So if you have any questions or comments, go ahead and leave them down below. And as always, thanks for watching.